bundled and run as one single service. And what that does is it limits your ability to experiment. It's hard to implement new ideas. When one thing goes wrong with your application, everything goes wrong. And if one part of your application needs to scale, you have to scale your whole application. That is not a modern architecture. If you are architecting to take advantage of the cloud, one of the great ways to do this is to build a microservice. With a microservice architecture, each component is built as an individual microservice that scales individually, that you operate individually, and for many companies, that you have resources that are individually assigned to that one microservice. And then you have a collection of different microservices that combine into a single experience for your customer. At Microsoft or at Amazon, we discovered a long time ago that refactoring our software into smaller services, we could move more quickly and scale more effectively. Because if these individual microservices are run separately, they're deployed separately, they're updated separately, they're scaled separately. And you can structure your teams around these services so they're experts in them as well. Back when S3 launched, 13 years ago, we built S3 with 8 microservices. We had a microservice that handled and processed requests. We had a microservice that metered data. And now today, behind the scenes for S3, we have over 200 microservices with individual teams that manage all of them. And all of those combined for the single experience of S3. So if you are moving to a microservices infrastructure or starting with one, you know how important it is to map your compute to exactly what you want for your business. And so we have 3 categories of compute: instances, containers, and Lambda functions. Today, many of our customers don't pick one. They use all of them for the different business needs that they have. Let's take instances. What I like about instances is that it really demonstrates the depth that I talked about. You can pick from any one of 190 instances for your application. And you know what? If your application scales and grows or changes over time, you can very easily swap out any instance you want. So we have general purpose instances. We have instances optimized for HPC or big data workloads. We've got the most powerful machine learning and GPU instance in the P3DN family. We've got processor choices like Intel, AMD for x86, and our new ARM-based Graviton processor that offer up to 45% lower cost for scale-out workloads. Now, with EC2, just like EBS, we are the only provider to offer the ability to take your instance, your existing instance, and add an option to it, like elastic graphics or elastic inference or elastic block service. And that is what you get when you get the depth as well as the breadth within our instances compute. Now let's talk a little bit more about containers. When I introduce these second and third categories of compute, I am going to give you examples of how enterprises are taking their move to the cloud and they're incorporating these technologies. So Elastic Container Service is a highly scalable, high-performance container management service that supports Docker containers and lets you easily run applications in a managed cluster of EC2 instances. But with ECS, you don't have to manage any of the container automation or the orchestration software or the virtual machine clusters